Oh, because I guess you just do multiplication. Yeah, that works.
Okay, 8.2c, so this is like day 3 of dealing with these fractions.
How many days of fractions?
Well, this is the last day of new stuff. From here, it's review, review, review. Test is next block day, but remember, it's a little weird the rest of the week because of testing and schedules and whatever.
So next Tuesday.
Next block day is our test. Monday is the counselor day. Tomorrow's the ACT day. So it's a little crazy, but we've still got plenty of days to learn and review.
Yeah, but this is next block. So it's not the same.
All right, when we say complex,
This week we have ACT.
what we mean by complex is fractions and fractions. That's what complex means.
Is that like always what that means in that?
That's what that means. When you say complex fractions, I guess I should box that up too. It doesn't just mean like, oh, that's a hard one. Like, no, it has a technical definition, not just, we didn't call it hard fractions or difficult fractions. Complex fractions has a specific definition, which means there are fractions within the fractions.
3 doesn't look very complex.
So yes, 3 would not be complex fractions. That's right. Even if you think it's hard to get a common denominator for 3, it's not technically complex. So that's what complex means. Okay, there's 2 ways to work these, and I always go back and forth on which way to teach it, and I just about decided to teach it both, and I went down to Miss Houston, and I'm like, hey, which way are you teaching these? And she's like, I don't know, I'm going to do both. I'm like, all right, same page then. We're both going to teach both, and if you like one way versus the other, then you can adopt the one way you like, and be done with that, and never use the other way. After we do both of them, we'll talk a little bit about advantages, disadvantages of either one, and then you can decide which way you want to go. One way is a little more formulaic, methodical, algorithm, process, but as usual, that's usually like the longer way, but maybe the safer way. The other way is quicker and faster, but you have to have a decent understanding of math to pull it off. Having said that, which way do you want to see first?
The second one.
The faster. Okay. Okay. So, I've got them labeled backwards in my notes. So, let's call that the fast way. I don't want to make it fast and slow. One's methodical, one's more, I don't know. Till someone comes up with a better name, we'll call this type 1 method. Clear all the denominators. That's the, just blow them away and then you're done, basically. So here's how we do that. We need to find a common denominator of the denominators. So yeah, we're looking at number 2. So I'm looking at my denominators. So AB would be the common denominator. Now we'll multiply top and bottom by whatever the common denominator is. In this case, AB. So I'm going to try to kind of work this over here, and we'll do type 2 there. So 2 over B plus 5 over A, 3 over A minus 8 over B, and I'm going to multiply the top by AB and the bottom by AB. First time through, I'm going to show all the work because this is the step that messes people up when they try this method. They're going to cancel wrong. So I'm going to show the steps. I'm going to put AB on everybody, even though once you do this a couple times, you're not going to do this. Don't really want you to do this. Because it's really not the fastest if you do it like this. That's right. Whoops, thank you. Okay, now I think you can see why we did that. What happens on this top left fraction? Just that top left thing. The b's cancel. And we're left with 2a. Right? We multiplied by ab to cancel out that d. Yeah, we're left with an a, but hey, worth it because it got rid of the b.
Wait, but does
Shouldn't there be two? Why wouldn't we put a at the bottom?
wouldn't AB multiply into the bottom part too?
No, because when you multiply fractions, you just multiply the top.
Because that's the common denominator.
What about this second term?
5B.
Yeah, the a's cancel, and I'm left with 5b. In the bottom, a's cancel. Well, Cooper, back to your question about multiplying top and bottom. I would say we did multiply the top and the bottom of the whole thing.
Okay. Just the tops of each
Correct.
portion.
In the bottom, let's see, the a's cancel, and I'm left with 3b. And then the b's cancel, and I'm left with 8a. And there's my answer.
I like this.
Again, I probably didn't need to show that middle step, but man, people start canceling weird things and losing things if they don't show it. What they'll do, here's what they do. So they write this step, and they're like, oh look, the b's cancel. And they'll cancel those b's, which is kind of right, but then, so they'll put the a there, but then they've lost the b, and they won't end up with a b right there because they said it canceled. Well, it canceled with this one, but it didn't cancel with this one. So don't be doing that, because it goes to both. And yes, it cancels on the first, but it didn't cancel on the second. So that's why I show this step the first time through, to make sure each term gets the AB. So all the denominators are canceled, and then whatever's left over in the top, fine, but we don't have any denominators left. Okay, type 2. So a separate way to work this. Fix the top, fix the bottom, keep it, change it, flip it. And by fix, I mean like add the top. Treat the top completely separate from the bottom, then treat the bottom separate from the top, and then put them together. So if I do that, if I want to add 2 over b plus 5 over a, let's see, I would need an a in the top and bottom, and a b in the top and bottom. This is fixing the top here. 2a plus 5b over ab, so there's step 1. Step 2, worry only about the denominator. 3 over a minus 8 over b. So again, this way is a little more methodical. It also matches what we were just doing yesterday and Friday, where we get a common denominator and we're adding. So this one needs a b, this one needs an a. So 3b minus 8a over ab. So I fix the top, I fix the bottom. Now I will keep it, change it, flip it. So keep the top, change it to multiplication, and then flip this one. AB over 3b minus 8a. Oh, look what happens. AB's cancel, and I'm left with 2a plus 5b over 3b minus 8a. Magic, same answer. So, method 1, quicker, if you can find the common denominator and if you can multiply and cancel correctly. Method 2, a little bit slower, but definitely more process, algorithm, method, if you're worried you're going to make a mistake, probably type 2 is the way to go, because do the same thing every time. Add the top, add the bottom, keep it, change it, flip it. Doesn't matter to me which way you go, which method you choose. Is not that one is better or worse than the other. There might be a method that's better or worse for you as an individual, but that's your job to figure out, well, that's too much, I don't want to do that, I can't figure that out, or, man, that's a lot of steps and I'm comfortable doing that. It's up to you. It's up to you.
On 4, can you just do one thing for one of the fractions and another fraction multiplied by something else?
So for number 4, tell me which method you want to use first.
The short one.
The short one, okay? So if you want to do the short one, you have to tell me, or you have to be able to figure out what the common denominator is for all of those.
And you can make them all x squared minus 9.
That's right. So that common denominator is x squared minus 9. I'm going to write it not as x squared minus 9, but as factored. That way it'll be easier to see who cancels. So x plus 3, x minus 3 to the top. X plus 3, x minus 3 to the bottom. And then maybe we see if we can eliminate that middle step I showed earlier. So on the top left fraction, what cancels?
X minus 3.
X minus 3 cancels, and what's left?
2x plus 3.
Yeah, either way. 2 parentheses x plus 3 or 2x plus 6, either way. On the top right fraction, what cancels? Yeah, the other way, everything. And so what's left? Yeah, plus 3x. And now we've fixed the entire top. All over. In the bottom, let's see, on the bottom left fraction, what cancels? X plus 3. And so what's left? 3 times x minus 3. And then on the bottom right fraction,
Just cancel them. Just be 4x.
right, just minus 4x is left. Now, we're not quite done on that one. We need to multiply it out. Maybe something cancels. See what happens. 2x plus 6 plus 3x over 3x minus 9 minus 4x. So 5x plus 6 over negative x minus 9. Can I reduce the 6/9? Why not? We cancel factors, not terms. So that's it for number 4. All right, there's not a lot of problems on this, so I don't really want to work any more complex fractions, because there's only 1, 2, 3 left for you to work. That didn't sound right, Jack, if I heard you right on number 1.
That's 6y plus 4, 2y. That's what I got.
So number 1, the longer way. 6y plus 4 over y over 2y plus 6 over y. Fix the top, fix the bottom, and then keep it, change it, flip it.
15b cubed plus 180 squared plus 216a all over 240. 216
Minus 216.
Wow, 216.
Oh, you land here regardless of which method you use, but
That's what I got.
What? Can I reduce the 6 and the 2?
No.
How about the 4 and the 6? Yeah, Kennedy's right. Like, so what do I do with this thing? I factor out a 2 from both. You could do that in your head and reduce everybody by 2, or you could do it like the more official way and show your work. We cancel factors, not terms.
What'd you use the common denominator?
X plus 5, X minus 5. But then, when you do that,
So on number 3, you can break it way down and then treat it like the kids in the back seat of the minivan. This guy says, wait a minute. No, I want all those 2s. Give me some more 2s. Ah, fine. I also want a 5. All right, have a 5. I guess I should have started with denominator 1. He's got the most 2s. But what doesn't he have? A 3 and a 5.
No, and the one in the middle doesn't have an A
Yep, he needs an A
and a B squared.
and a B squared. This one needs a B cubed.
Guy on the right needs an A.
Guy on the right needs an A.
There you go.
And
24, so.
he needs, I'm going to do it the long way. He needs 3 more 2s and a 3. Now, that looks like a lot of multiplications, but you only have to do it once, right? Because now that's the common denominator. So whatever 8 times 15, or this is probably the easiest way to do it. 10 times 24 is 240. 240 AB cubed. Ooh, major mistake I made. I mean, I can still have time to fix it. What's not right about what I wrote?
There's nothing up the top.
Yeah, I didn't put it in the top as well. I got so focused on the bottom, I forgot to. So 15b cubed. Luckily, I put it in a different color, so it's easy to spot. So 4 times 25, that's 100. So 100 AB squared. And then 8 times 3 is 24.
This one doesn't need an
9 times 24. The 240 minus 24, 216. 216A. Definitely can't reduce any A's or B's. That's only got a 3 and a 5 in it. That didn't have a 3, that didn't have a 5, so yuck. Yuck, but not complex, right? That's not officially a complex fraction. Do we need a long division problem in case Miss Houston walks in with a...
I wish I just hope she doesn't.
That's one method of life. Just hope the bad man doesn't show up at the door with the bill.
Where'd you get, Jack?
Not that I just called Miss Houston a bad man.
X plus 21 over